This scenario utilizes Cohort Explorer, so we will need to open the Explorer. In the Tools drop-down, select Cohort Explorer. This opens the Cohort Explorer tab and shows you the unfiltered cohort of all available patients in the right portion of the window, and the available data or traits in the left. The traits are organized into folders, just like Windows files in the directory structure. You can at this point double-click on those folders and explore around. There's a back button and an up button below the Tools drop-down. Use these to return to your previous position. As you drill down into the folders, there is a graphic representation below the back button, showing you your location in the hierarchy, with the highest level being All Items. These are hot buttons as well, so you can return to the highest level by clicking on the All Items button. To begin this scenario, be sure you are at the All Items level. Our first task will be to limit our cohort to only those participants who have breast cancer. This is done by limiting the participants to those that have a tumor tissue site of breast cancer. We are going to look for those patients with a tumor tissue type of breast cancer. To do this, we could navigate to the Participant Traits folder, then the Participant folder, and find the trait called Tumor Tissue Site Trait. This works if we know where to go. However, let's assume that we do not know where to look. So the alternative way is to find it using the search function. Reducing the cohort of all participants to those that have tumor tissue type breast cancer is easily done by using the search function. In the search box, type tumor, then the return key, or press the magnifying glass icon. The results of the search are seen in the window below the search box. Find the trait called Tumor Tissue Site and select it. Notice that when you select it, a few icons show up. One which looks like a funnel to filter the cohort, and one that looks like a group of people to group the cohort. The funnel allows you to filter the cohort and reduce the cohort to only those patients that match the selection of tumor tissue site breast. The grouping option takes the existing cohort and splits the cohort into groups based on your selection. We then select Filter on Specific Choices and select Breast. In this demo, there is only one choice. However, when other TCGA data is loaded, additional choices like lung will be possible. Selecting the Apply Filter button, or executing this filter, will take the existing cohort of participants and reduce it to those with tumor tissue site of breast. PI3K variants are the most common oncogenic variants in breast cancer. In particular, PIK3CA has activating variants in a large percentage of breast cancer variants. Cohort Explorer provides an easy way to find out what the breakdown of mutations is within the cohort in your research center. Now we're going to look for those patients with the molecular variant gene symbol PIK3CA. In the search box, type PIK3CA and type return, or press the magnifying glass icon. When the search is complete, selecting the result, you can see the discovery of 3 traits where PIK3CA are found: gene symbol genetic variant, gene symbol variant observation, and gene symbol expression. For our purposes today, we will be using gene symbol variant observation. We are using this because for this analysis, we are interested in the observations of sequence data in patient tumors, where somatic variants occurred in PIK3CA, not in the expression levels. Click on the filter icon. Once the filter options are open, notice that the PIK3CA is selected as part of the genetic variant observation folder. PIK3CA is automatically selected as part of the navigation to the filter from the search results. You can see that there are 21,737 possible choices in the list, of which PIK3CA is one. If we wanted to look for another symbol, we could use the Search Choices box above the list. Selecting the Apply Filter button, or executing this filter, will take the existing cohort of patients and reduce it to just those with the PIK3CA molecular variant. Now we want to investigate the relationship of different amino acid changes. To do this, we need to navigate into the Genetic Variant Observation folder. This is done by returning to the All Items level by clicking the All Items button above the search box. This returns our view to the top level. Navigate into experiment traits by double-clicking on the folder in the navigation window, then double-clicking on the genetic variant observation folder. All the traits contained in the genetic variant observation folder are now displayed in the navigation window. Amino acid change is listed right at the top. The list is alphabetical. If we wanted, we could use the search to find it as we did for PIK3CA. Within Cohort Explorer, it is also possible to get the breakdown of the variants within a particular gene. This is powerful because it allows us to easily identify the relative frequency of individual variants. Here the data is broken down by the amino acid change, but we could easily break it down by activating or damaging variants, for instance, if that annotation was available in the system. Further, we could also apply a filter here and identify the patients with particular PIK3CA variant or only those damaging variants. What we want to see now is how many of these PIK3CA variant participants fall into each of the amino acid changes. To do this, we're going to group the current cohort based on the specific amino acid change types. Find and select amino acid change. Select the group icon, the one which looks like a group of people. Once you are looking at the grouping options, select Group by Individual Choices to group the current cohort into different groups, one for each value of amino acid change. Now select the Group button. The cohort on the right is now organized into different groups. The summary tells us that there are 60 groups. Each icon shows the value, the count for that value, and the percent of the total count that value represents. Our goal here is to look for amino acid changes that are significant. So first we'll want to use the sort feature located at the right above the icons in the banner and sort the values so the highest counts are at the top. Select the 9:1 option. The result is that the amino acid changes with the highest count are bubbled to the top of the display. We also might find value in changing the view from an icon-based view to one which shows the group details. This creates a table of the amino acid changes with the count and percent values. The group details view is nice for the publication of papers. It gives population frequencies and proportions which are often required for publication. After looking at the different views, return to the icon view. If we wanted to narrow our cohort to those patients with one of the specific amino acid changes, like H1047R, the one with the largest count, we can double-click on the H1047R icon. The result is a cohort with the reduced count of participants. Also note that there is an additional breadcrumb on the right side of the display called amino acid change, H1047R. This breadcrumb is the one created based on applying the filter to narrow the cohort to those with the H1047R variants. For our purposes going forward, we want to return to the previous cohort. To achieve this, simply click on the gene symbol PIK3CA. This is the breadcrumb just to the left of the amino acid change breadcrumb. This will return the cohort to the previous cohort.